7, and then group 2. Okay, I think we can start with group 1, and I've been the supervisor of this group, so I'm very proud, but I don't want to interfere with your voting, but these are my favorites.
Hello everyone, we're group number 1 and welcome to our group 4 project presentation. As you now might know, this year's group 4 projects are all about food and we decided to work with candies. And to be more specific, we chose to research the question: what the dice does M&Ms and non-stops consist of? In order to find out, we decided to do a chromatographic investigation on their colorful sugar coating, which we will now explain step by step. To begin with, we looked for the best dissolvent to get the pigments of the candies without also getting the chocolate into the mixture. We tested 3 different types of liquids: acetone, ethanol, and water. We filled 3 test tubes with these liquids and put in a non-stop to see which liquid dissolved the pigments the most. We found that water was the most suitable to us.
Okay, so the next step was to get a high concentration of each color from the M&Ms and the non-stops. We used 1.5 milliliter of water for the non-stops and 0.5 for the non-stops and 1.5 for the M&Ms, since they were like twice as big. And also, to get a high concentration, we put each color in a test tube with the amount of water mentioned earlier, and then shook it until the color were dissolved. And then switch candies, which account for candies, but we kept liquor and or the liquid, and then we repeated this 5 times to get the very dark concentrated color. And afterwards we took a small amount of the concentrated colors by using capillaries. Hope you know what that is. Yeah, and applied it to the chromatography paper. So we dried the colors that were applied, and then we repeated the progress until we got this strong concentrated color that we wanted.
Yeah, so last step was to put the chromatographic paper in the glass containers that consist of small amount of water, so the water could barely touch the bottom of the paper. And in the mobile phase, we expected that the water, when it was coming, it would go with the water, with the color, and take it and shape it so it goes upwards. That we will show later in a card. Anyhow, we noticed that it didn't work that well, and that's why we changed the solvent to heptane, and that didn't work either, because we didn't know, we weren't sure. We students and the teachers were testing, the pen you write on the board, but it didn't work also, so we were disappointed to have failures, but that's just a part of the experiment. And yeah. The results. Yeah, we will hand out the paper.
Okay, you can hand out the papers, right?
Yeah, just it.
So, the results then. As we said earlier, that we figured out that with the chromatographic paper. Yeah.
So M&Ms were more soluble than non-stops, especially blue and red ones. You can see on the
You can also
papers.
see that. And also it's possible to see that some of the colors contain more than one dye, because you can see how the colors have reacted with the chromatographic paper and reveal different colors. So we're going to come back to that, I think.
Yeah, we could also see some packages which in numbers belongs to with color candy. During the stationary phase, water didn't seem as perfect as we thought. Many of the colors stayed the same and barely moved across the chromatographic paper.
And that's why we decided to test with heptane. But we failed even more. And also we can say that the reason why we decided to try with heptane is because, as it says here, water is polar, and so is the chromatographic paper / dyes. So we decided to try with heptane to see if it would make a strong reaction. But since it failed even more, we can say that the dyes are polar as the water, and therefore it resolves better and reacts better.
So as Adrian said before, the best solvent was water. And M&M's pigments are much more soluble in water than those non-stops. The blue ones and the red ones.
Yeah, the blue ones was from coal, right?
Yeah, but I'm gonna take that later.
Yeah. Okay, so we will come back to that. And here's a picture right after.
Okay, so this is some fun fact about what you're eating and where the colors are from. The yellow ones is from turmeric, and the red one is from mice, and the blue is coal tar, and the E60s, carrots and spinach and seeded fruits. And also something interesting is the E172 is frost. You did not know that. And the black one, the E153, or is it the black one? Or is it black? Yeah, that's coal tar. Oh no, the 171 is black. And the one down there is white.
Just like the colors of the letters.